This is a CDF which focuses on the periodic change of a Gaussian wave packet in a double potential well when it is prepared in a particular way, for instance, the left one. A possible example is related to the inversion of the ammoniac molecule. The double well model is ubiquitous in chemical physics. First of all, we want to explain more precisely the example of ammoniac. Ammoniac molecule exists in two different configurations related to two minima of the double well. By assuming an harmonic potential for each well, the two local parabolas allows us to build a zero-order Hamiltonian. For this molecule, tunneling effect through the barrier acts as a perturbation for the zero-order Hamiltonian and causes a conformation inversion of ammoniac. Besides, when assuming a two-state model built from the two ground states of the zero-order Hamiltonian, it is possible to illustrate that probability to populate the two states starting from state 1, and thus the transition probability between the two conformations is related to the Rabi formula. In addition, this probability oscillates with a Rabi period given by this formula. Theta sinus is related to the amplitude of oscillations and depends on the difference between eigenvalues from the diagonalization of Hamiltonian matrix with the tunneling effects perturbation.
In this case, the two wells have the same deal. Thanks to the tunneling effect, the wave packet crosses the barrier and goes from the left well to the right one progressively. Then, the wave packet comes back to the left one. This phenomenon takes a time called Rabi period. It is possible to observe it on this figure. At the time of the half of a Rabi period, all of the wave packet is in the right well, and after another half of a Rabi period, all the wave packet comes back to the first well. We can also observe a link between the gap between the two wells and the Rabi period. Indeed, the gap increases, the tunneling effect decreases, and therefore the coupling between the wells. You can observe that the gap between the wells increases, the gap between the two lowest eigenvalues decreases, and the Rabi period increases. If the gap between the wells decreases, the coupling becomes very important, and also the Rabi period decreases. But in this case, the match with the formula may decrease a little bit, because the two states approximations become less consistent.
In this case, the right well is less deep in energy, but oscillations are always observed. However, when the time equals the half of Rabi period, the wave packet is always shared between the two wells, contrary to the general case. Indeed, the amplitude of probability is not 1 when the two states are not degenerate.
That is why the match between wave packet oscillations and Rabi period is less consistent, because the two states approximation is not appropriate anymore. Nevertheless, when the time reaches the Rabi period, the observations are the same than the first case.